Hi, I'm Priya Justine Saranto Galvan, and I'm going to expose my poster of mechanical and microstructural evaluation of CNT nickel dope wells in 304 stainless steel. Well, double wall carbon nanotubes stand out for their mechanical properties due to their high tensile strength. On the other hand, nickel used as dopant acts as an austenite stabilizer and improves the solubility and dispersion of the elements, contributing to a more uniform microstructure. In this study, lab joints doped with double-wall carbon nanotubes and nickel were fabricated using the gas metal arc welding process assisted by a Yaskawa Motoman robot, with AC304 stainless steel as the base material. The objective of this investigation is to evaluate the mechanical and microstructural properties of lab joints in AC304 stainless steel doped with double-wall carbon nanotubes and nickel. This study aims to determine the relation between concentration of these dopants with the influence in the tensile strength, mechanical performance, and uniform microstructure. In the methodology, we calculate the desired concentration. We use nickel in 5, 6, and 7% of concentration, and CNT with 1.7, 3.3, and 5%. We place the doping material in the joint and weld the located area. We cut the samples and prepare for test. We perform the tensile test and microscopic analysis. The results show that doping is not always beneficial, although almost all combinations outperform the original material in the strength. In most cases, ductility was reduced. The concentration of 6% nickel with low CNT was the most favorable, improving both strength and deformation. Concentration of 7% nickel were useful only with moderate CNTs, since they maintain a behavior close to the original. On the contrary, high CNTs were detrimental at all nickel levels, probably due to agglomeration and loss of continuity in the metal matrix. In the results, we obtained the dope wells generally showed an improvement. The combination with 6% nickel and low CNT content stood out, as well as 7% nickel with moderate CNTs, which reached the highest forces before fracture, we can see in the graphic in tensile test. The SEM and EDS show the presence localized of the dopants and some microporosity, compromising its ductility. Well, we conclude that doping with nickel and double-wall carbon nanotubes may improve the mechanical behavior. The best results were obtained with 6% nickel and low CNTs, reach an enhancement in both resistance and deformation compared to the original material. On the other hand, high contents of CNTs were negative in all nickel levels, so it's recommended to keep their content on moderate levels. We are grateful to Universidad Popular Autónoma del Estado de Puebla and Centro de Servicios de Alta Tecnología CESAT, and to Universidad de las Américas Puebla UTLAB for their support in the realization of the trials. In the right bottom, we have a QR code for the references in this investigation.